So our topic is forces, which has to do with Newton's first law, second law, and third law. So first we're going to start off with Newton's first law, and the major concepts are an object at rest will remain at rest unless force acts on it, and an object in motion will remain in motion at constant velocity, unless of course the force acts on it as well. And this all equals to inertia. Inertia is the tendency of an object to maintain its state of motion. So if there's a greater mass, then it's going to equal a greater inertia, because obviously the state in motion, or the object that has the greater mass, will cause more. Is Newton's second law, and the concepts around that is a net force acting on an object causes the object to accelerate in the direction of force. For instance, if someone is pulling on a wagon, then the wagon is going to move along with the person as well, because it's being pulled in that direction. Secondly, the acceleration of an object is directly proportional to the net force acting on the object, and inversely proportional to the mass of an object. So the first equation that we're going to be taught is net force equals mass times acceleration. And here's an easier way to remember it when we were taking quizzes and tests. Another thing we have to remember is 1 Newton is that resultant force which imparts on acceleration of 1 meter per second squared to a mass of 1 kilogram. And the second, or not really the second, but just a key to back up, that mass is going to be measured in kilograms and acceleration in meters per second squared. And force, obviously, Newton, which is the last of them. And when we think of Newton's third law, we always have to remember for every action force, there must be an equal and opposite reaction force. And forces always tend to occur in pairs. For instance, skateboard, riding a skateboard, somebody. The runner is going to have, positive force, and then when the runner or person is riding the skateboard, they tend to move, their feet back to push on the board. So then the board is going to have a negative force. When we think of a force, we usually imagine a push or pull on exerted of some object, and forces cause changes in motion of objects, stationary, which is, staying the same, or moving. Tension in weights and mass times gravity. Gravity is always going to be 10. So given mass, which is 5, you multiply it by 10, and it's going to give you 50 newtons. And these 50 newtons, or any number given here, it's going to go directly to normal force, which is up here. And normal force is just what's given off of weight, so it's only 50 newtons. Then to solve the next part, it's frictional force. So frictional force is always going to go to the left, and it's going to be F for it when we're trying to solve it. So little f is going to equal mu times newtons. Mu is mostly always going to be given, but there are times when it won't be. In this case, it's going to be given because we're starting off with simpler problems. So mu, it's given. So for example, 0.2. So in this case, 0.2, and then times it by newtons, which is given here, 50. So 0.2 times 50 is going to be 10 newtons, and then 10 newtons here. And usually it's going to equal here the same thing if it's balanced. To get the net force, we need to subtract the applied force, which is this one, minus the frictional force, which is this one. So it's going to be 20 newtons minus 10 newtons. So the net force is going to equal 10 newtons. And then to get the next thing is acceleration. So acceleration is going to equal the net force divided by the mass. So as we got the net force, which is 10 newtons, we divided by 5 kilograms, which was given inside the box. So 10 newtons divided by 5 kilograms equals 2 meters per second squared.
Okay, so a student moves a box of books down the hall by pulling a rope attached to the box. The student pulls with a force of 185 newtons at an angle of 25 above the horizontal. The box has a mass of 35 kg, and d mu between the box and the floor is 0.27. Okay, so first we're going to have to write or draw our diagram. So the box is 35 kg. And then the angle going upwards would be 185. And then the angle would be 25. And then mu, we're just going to put in the corner, 0.27. So if you're finding weight, it would be the force going downwards. So weight equals mass times gravity. Mass is 35, and then gravity would be 10, which would be 350 newtons. Now if you're finding normal, it's the force going upwards, and this would be weight minus F of y. So weight would be 350 minus F of y, and we're going to have to actually find that. So F of y is 185 sine 25, and then F of x is 185 cosine 25. 185 sine 25 would be 78.1, and 185 cosine 25 would be 168. For normal, we have to use F of y, which is 78.1. So 350 minus 78.1 would be 272. Now, if you have to find friction, we're going to have to use friction equals mu times normal. So mu, they already gave it to us, which is 0.27. And then normal would be the force going upwards, which is 272. It would be 73.4. And now if they ask you to find acceleration, it would be acceleration equals F net over mass. And F net would be 168 minus 73.4, 94.6. And the mass would be 35. It would be 2.70 meters per second squared. So if they tell you to find tension without having friction, first you're going to have to find acceleration. And that would be A equals F net over mass. F net would be 12 right here. And then the mass would be adding both of these, which is 6. And that would be 2 meters per second squared. Now for step 2, you're going to have to isolate one of the boxes. And the easiest one to isolate would be 2 kg. The sum of all forces equals M times A. So tension equals 2 for mass, and acceleration, which we found right here, and that would just be 4 newtons. The ball hits the first domino, then the rest fall after. Nail is being hit with a hammer. When the hammer stops being hit with a nail, the nail moves from rest into the wood. If you put a block on top of a plastic water, it will remain at rest. Objects with greater mass have greater inertia. The small car has higher velocity. The big car has less velocity. So the small car will go faster than the big car. The tension force is directed along the length of the wire and pulls equally on objects on the opposite end of the wire. The tension force is the force that is transmitted through a string or a rope.